Alright, in this video, we will be discussing 10.1 and 10.2 of Honors Chemistry. Chemical kinetics is what it's about. It studies two things: the rate of reaction, the speed at which a reaction takes place, and the mechanism of reaction, which is the steps. So the collision theory states that particles must collide in order for a reaction to take place. Well, duh, a reaction can't take place if particles don't collide. If particles don't collide, there's no reaction possible. But it has to be an effective collision. The particles must approach and collide with one another at the proper angle and with the proper amount of energy. It's necessary for old bonds to be broken and new bonds to be formed. It's like pool, where you have to use the white ball to hit the 8-ball in the proper fashion in order to get to go into the hole. Nature of reactions, concentration, temperature, catalyst, surface area, all affect this. The chance of a collision being successful is about, I think, 1%. Hang on. Percent of successful particle collisions is... Why can't I find it? I think it's about 1%. So ionic substances, reactants between them take place pretty quickly. Because they're already in water, so they're already hydrated and spread out, and the old bonds are already broken. For covalent, the bonds must be broken, so they are slow. The more concentration that there is, it usually increases the rate of reaction in a homogeneous solution. It's still the same for gases and liquids in a heterogeneous solution. So it can increase the pressure, decrease the volume, increase concentration in order to get faster collisions. Temperature, for every 10 degrees Celsius or 18 Fahrenheit, we increase the temperature, it doubles the rate of reaction. So think about it almost in this fashion. Yesterday, the high temperature in New York City was about, I think, 21 degrees Celsius. I could actually check that right now. The high temperature in New York City yesterday was 22 Celsius, actually. 22 Celsius. And actually, so it's perfectly, the low was 11 degrees Celsius. So, between the high in the late afternoon and the low just before midnight, the particle collisions, that the rate of reaction would have slowed by 2 times. Not the case under the Farmingdale measurement, though, because 10 and 17. But it is the case for Central Park, and it's actually a good example to see how, even in the course of one day, you know, and a catalyst will speed up, but it's not change itself in the reaction. Surface area, as you increase the surface area, you increase the rate of reaction. You can do this like grinding it into a powder. This is an example of how you turn 24 centimeters squared to 48. The law of mass action indicates that you have AA and B, which are the products, and then if you add an exponent to them, then if you add an exponent to them, it will affect the rate at which one might work more than the other. But in this case, you have a second order reaction between H2 and I2 to form 2HI, and that has no exponents. So that's 10.1 for you. 10.2 is a lot more painful. This goes into more of the nitty-gritty chemistry stuff. That's actually what's known for making honors chemistry so notoriously hard. It's when you get into like this nitty-gritty stuff that we're about to dissect right now. So, The mechanism of reaction is the reaction pathway. If you have 2A plus B equals C, you're going to have this I in between. So there's a series of steps to form this net reaction. During this intermediate or activated complex, you have a temporary particle that will exist when reacting molecules collide at a proper angle with the proper amount of energy, and it's very unstable. They could go back to the original, or they could form a product. The activation energy is the minimum energy needed to form the activation complex. The rate determining step is the slowest step in a reaction that will determine the rate of the total reaction. Take a look at this. Person A is to write the addresses of the sender and receiver. B is to fold and stuff the envelopes. C is to seal and stamp the envelopes. Step 1 is the rate determining step because it takes the longest to accomplish. Now, if you add an additional person to seal and stamp, step 3 would be faster, but the overall step wouldn't, because person A, you still have to wait for them to get it. Now, I actually wanted to ask, and I got to ask this question, and I was very confused by the answer. Well, if you have more people to help seal and stamp, why wouldn't the overall thing be faster? Yes, you'd have to still wait for person A in order to get the addresses on the envelopes. But if you think about it, if there were 2 people, wouldn't it still be done faster? So, in this case, I think the answer is yes. In the sense that the mail would probably be sent out a little bit faster. But what we have to understand is that when you look at it over the course of a day, when they're sent out in blocks, it might not actually matter all that much. They're definitely not getting the envelopes any faster. They might be able to send them out a little bit faster. But also the thing is that analogies are just that, analogies. So in chemistry, it works different. Plus, as we've discussed, things can be negligible. So there might be a little bit of an increase. But if it's negligible, we say there's no increase. If it's negligible. So if you have fast, slow, fast in this case, step 2 is the rate determining step. See now it says that it would have little or no effect on the overall rate of reaction. See, that's why increasing the concentration of any reactant usually increases the overall rate. You must increase the concentration of a reactant that is the rate determining step. In this very complex equation, AlCl4, H, and Cl are the intermediates. AlCl3 is the catalyst. It comes out unchanged, but in order for it to be a catalyst, it has to first show up on the left and then show up on the right. It can't show up on the right first, then on the left. The net reaction is Cl2 plus... Oh my god, it actually isn't. Because this is on both sides. And I'm an idiot. In this case, it's Cl2 plus C6H6 plus H plus AlCl4 equal... No, it's Cl2 plus C6H6 plus H equals C6H5Cl plus HCl. If you increase C6H6, it'll have no effect. Decrease Cl2 and you'll decrease the rate of reaction. And increasing temperature will always increase the rate of reaction. So that was that video.